there's your title. Equation. Can anybody define an equation here? What the heck is an equation? In your own words. You've seen this in divisional and multiples in junior high. Even before that, what the heck is an equation? Somebody. Like a problem? A problem that you have to solve? Okay. I want to get a little more precise. I want to tighten that definition up. I like how you're talking about other things, Galvan. Before we define it precisely, can anyone give it a shot? What's an equation?
Variable, also symbols like as multiplication, minus.
Beautiful. It's all that's involved. Beautiful. And it involves a word expression too. Let's define the word expression before we define it in an equation. So even the word expression, you've seen that before in math, and if I were to put a gun to your head, no one would be able to define that if your life was on the line. But you've seen that word expression like millions of times up till now. Now you're going to know what it means. Watch. Check this out. Go to write the word expression. Any collection of numbers, variables, and operations. Any collection. And if you know this already, you're good. Any collection of numbers, variables, and operations. Now, you guys know what numbers are. You guys know what variables are. What the heck is operations? What are operations? For those who don't know. Yes, Chris. Nice. Very good. So if you don't know what operations are, underneath, put in parentheses, or maybe to the side, in parentheses, going to put adding, comma, subtracting, multiplying, dividing. So think of what an expression means now. Any collection of these three things, this, and this. I can make one up off the top of my head quickly. Any collection. There's literally an infinite amount of possibilities of expressions. I'm going to make one up. Ready? Example. I'll put EX for example. 2x plus 3. Notice that. That's an expression. It's a collection of numbers. 2 and 3 are the numbers. Variables is x. Operations. How many operations, Galvan? You sure? Right, huh? 2x means 2 times x, so there's multiplication, and then there's addition. So this expression has 2 numbers, 1 variable, 2 operations. Beautiful. Now let's define an equation. Look at this. We know what an expression is now. It's a collection of numbers, variables, operations. Now look at the definition of an equation. 2 expressions that are equal. That makes sense. Every equation has 2 sides, the right side and the left side. Boom. I'm going to write that down. Left side, whatever's on the equal sign, and right side. Pretty straightforward. Go to write the goal of every equation. Ronaldo is scoring a goal. The goal, every time you see an equation, this is the goal. So write that down. To get the variable by itself, isolate on one side. It does not matter what side the variable is by itself on. Okay? So I put this Ronaldo picture up so you remember the goal of every equation you ever come across. If it's a one variable equation, you want to get that variable by itself. That's the whole point. So the goal is to get the variable by itself. How do we get the variable by itself is right here. Write that down and write those sentences there. How do we get the variable by itself? By getting rid of whatever numbers that are next to the variable using opposite operations. Make sure that you do that whatever you do to one side of the equation, you must do to the other side of the equation. And opposite operations are these. Multiplication and division are opposites. Addition and subtraction are opposites. All right, example 1. Example 1 in your notes. Let's solve -3 plus x equals -10. -3 plus x equals -10. Yeah. That's what it is. That's a deep conversation. Yes, sir. Just a minute. There's 2 examples. All right. Godfrey, what's the goal of every equation? Right. And how do we find the value of x? Let's just add. Who keeps answers? Add -3? All right. Should I add -3 to both sides?
Yes.
Let's see. Add -3 to both sides. Let's see.
No, but like you make it into positive. The 3 is positive. You add 3 to both.
Add 3 or -3?
Add 3.
Okay, I'm sorry. Hold up. If I add a -3 to both sides, look what ends up happening on the. I'm gonna bring down the equal sign, by the way. It won't not. Look at -3 plus -3 becomes -6, huh? We still have an equation that's still equal. The left and right side are equal because look, we did the same thing to both sides. It's like a balance. We did the same thing to both sides. But x, we're no more near getting x by itself as we were the first step. Right, we can still solve it. Right. At this point, we can add +6 to both sides. Excuse me, but then we go. We can add +6 to both sides to solve it, but let's just go back over here. What FedEd really meant was what, FedEd? Add 3 now, because you want to get rid of this 3. You want to get rid of whatever numbers that are next to the variable. So I'll add 3 to the left. Look at the left side and the right side. I'm not going to add 3 twice to the left. Look at. I'm not going to do this. At this point, if I add a 3 here and 3 here, I'm adding actually +6. Because look at 3 and 3 is 6. I'm adding 6 to the left and nothing to the right side. An equation is like a balance. Whatever you do to one side, you got to do the other. So I'm going to add the 3 over here. And bring down the equal sign. Always bring down your equal sign. So I have x. -3 plus 3 is 0. 0 plus x is just x. And then I got a -7. This is our solution. All right, example 2. Y divided by -3 equals 6. Y divided by -3 equals 6. So here I see that on the left side I have the variable y. I want to isolate it. That means get it by itself. So what number I have to get rid of here? The -3. It's on the left side with it. What operation is being done to the -3 right now? Division. What's the opposite of division? Acosta. So look what I'm going to do now, you guys. Check it out. To get rid of the -3, I'm going to do the opposite of division, which is multiplication. But whatever I do to one side, I got to do the other. I'll multiply the left side by -3, and I'll multiply the right side by -3. Look, I use a multiplication symbol. I can do a dot or a parenthesis. And bring on the equal sign. What ends up happening? What crosses out? Right, because look at this, is really 3 over 1, huh? -3 over 1 is still -3. I just left it as a fraction because I'm dealing with a fraction right here. And when you multiply by fractions, you can cross cancel. These -3's cancel out. So all I have is 1 here and 1 here. So 1 times y is just y over 1, but I don't have to put the over 1 because everything's over 1. It's unnecessary. So I really have just y in the end. 1 times y is y over 1, which is just y. And then 6 times -3 is a -18. Here's your solution. We're done. You know you're done when a variable is by itself. Okay. I said 2 examples, just one more just for giggles here. One more example. After this one. Example 3. When I write it down, Doctor, tell me what to do and you can get out of here. Tell me what to do after I write this down, you can go. Ready? Example 3 is -10 equals -5x. What did I do, Godfrey? Close. What side is the variable on here? So I'm going to keep the variable on the right side, and I'm going to isolate it on the right side, and I'm going to leave it on the right side. The first 2 examples I left on the left side. Look at y is here on the left, x on the left. It doesn't matter what side the variable is on, as long as it's by itself. Add 5, thank you, close. You should divide by what? Close. Miss Reza. Divide by 5? Divide by a -5. Totally different numbers, huh? Watch this now. Why'd you pick division, though, Godfrey? Just for the sake of students who don't know, why'd you choose division? Nice, perfectly said. 5 times x, this is multiplication, 5 multiplied by x. So I do the opposite operation, and you wrote that down shortly, about 5 minutes ago. Look what I do. I bring down the lines, my leftover bar. I call this like my leftover bar. What's left over after the dust settles, after I do something to both sides? I bring down the equal sign. X. What's -5 divided by -5? 1x. But I don't have to put the 1 in front of the x because that's actually, it's understood to be there. Because how many x's are there? 1. But you don't have to put the 1 because that's just 1x. This is one of them there. 1x equals 2. There's your solution.